Okay, year 12, let's look at the last section in alcohols. We have to look at the top left there, compare and contrast fuels from inorganic sources to biofuels including ethanol. What they mean by inorganic sources is petroleum and like other hydrocarbons. Yep. So fossil fuel stuff. Okay. So biofuels, biological fuels. Okay. It's a term given for fuel sources that are biologically derived that are renewable. Okay. I know that fossil fuels are biologically derived as well. A long time ago from algae and plants and stuff like that from swamps. We talked about that earlier, I think last chapter, sources for hydrocarbons, but here we're talking about short-term stuff, okay? Stuff that we can grow, okay? So they're renewable in that they can regrow again each season or in the matter of, a couple of years, okay? So I can't even talk today. They can be constantly replaced by new crops and ideally, and here's the idea, this is the big pie in the sky, if I can use that term. Ideally, they'll take the carbon dioxide out of the air that has previously been put into the air from consuming this fuel, okay? So previously emitted from burning biofuels. So that's the idea. The idealistic view is if we can grow all these crops to give us our fuel, and that will take in carbon dioxide, and then we can combust it, and that'll give out carbon dioxide. If we kept that as a neat circle, it'll be a perfect world. But the trouble is that we don't have the crop sizes, and we need too much fuel. It's not going to work, okay? So it's an idealistic way. There's some shortcuts to get around this. There's some other ideas we'll talk about, okay? So two main biofuels that we need to concentrate on and used in Australia: ethanol from crops, and also what we call biodiesel. So it's diesel from another source, okay? So here's a slide on bioethanol, and there's a good video to watch too. I'm sure I linked to that from the periodic table of videos all about bioethanol. Okay, so it's ethanol produced by the fermentation of cellulose and sugars. So crops such as sorghum, corn, wheat, and sugar cane. Okay, so we're growing these crops and then we're fermenting them, so introducing yeast and stuff like that, and with cellulose you'd need some enzymes to break them down, and the yeasties will go about their thing and make it into the alcohol, okay? Look at that. An enzyme is needed to break down the polymer or the cellulose into simpler sugars and monosaccharides before the yeast will ferment them, okay? The heat of combustion for ethanol is lower than the petrol mixture. So, you're getting less bang for your buck there, okay? If you want to think about it that way. The heat of combustion, getting less kilojoules per mole out of ethanol than you would out of petrol. So that's one sacrifice that you're making by using ethanol. So what ends up happening is you get about bioethanol and petroleum mixtures at the petrol station. And they have a slightly lower heat of combustion than full petrol, okay? More fuel needs to combust to give the same amount of pure petroleum fuel, okay? So if you want to give the same energy out of bioethanol, you got to burn a lot more, combust a lot more, okay? Most petroleum bioethanol mixtures are at 90-10. So the smaller heat of combustion is very minimal then. You don't notice it too much when you go and buy E10 and fill your car up then, okay? So that's one small negative to it. Another negative impact for society is that, if we're hoping to grow all these crops, it's taking up productive farmland that's going into energy rather than food or farmland production, okay? So that's one negative. But, you've got a lot of agricultural problems with waste farmland anyway, and raising beef. Should we raise beef when it takes so much water and resources anyway? It's a huge debate to get into, Okay. Also, I'll just add in there, there's some problems adding too much ethanol to engine parts and stuff that are plastic as well. Okay, so most cars these days are produced with seals and stuff like that that can handle about 10% ethanol, no problem. But start adding a little bit more into them, and the seals and all that don't last as long, and they rupture more quickly and stuff like that. But most cars these days are made with being resistant to about 10% ethanol. Okay, diagram on the right, we've got the process here. Okay, so where should we start? Okay, so we're getting here they're looking at bioethanol. I can't talk. It's looking from aquaculture or taking it from algae. Okay, it doesn't matter what the source is. What they're doing is basically taking whatever that plant stuff is, breaking it down into smaller chunks, or milling. You can see these two processes here. And then they're adding a bit of liquid to get it into a liquid state. And then what they're doing is, see these white Pac-Man, they're calling them enzymes. So they're using enzymes to break those sugar chains down into single sugars. Okay? So breaking the cellulose down into glucose. And then they've represented in the next stage there, they've put in the yeast. So the yeast is converting it, so you're getting fermentation, okay? And then you're getting a mixture of stuff, and they're separating the mixture through distillation to get out the ethanol, and then they're adding it to fuel. That fuel is pumping out smoky gases. Do you like my scribble there? And the idea is that that CO2 that comes out is then drawn back down by your new crop. Okay? Very idealistic. Still worth doing it in a small part, I feel personally. But it's a very idealistic way. I think the best option is to go with sun power and wind power and electrical power from renewable sources like solar and wind. Okay, that will always win out. But anyway, we're using it now. It's helpful in a little bit. Okay, I've had enough rant about bioethanol. Biodiesel. Okay, so diesel is a fuel that contains a mixture of hydrocarbons from 88 to 21 carbons in length. Okay, so we use diesel when we get the hydrocarbon mixture out of crude oil. Okay, so that's just normal diesel. We can make diesel though. We can call it biodiesel. We can make it from a reaction from fats, okay? So vegetable and animal fats have a certain structure that when we do a chemical reaction, parts of it will come away and be hydrocarbons that are 88 to 21 carbons in length, and then we can use it as diesel, okay? And so we can get corn, palm, peanut, sunflower, and coconut oils, pretty much any oils and fats from animals and all that will do it, but usually we're using corn, palm, peanut, sunflower and stuff like that. The source of biodiesel is renewable, and the biodiesel is being made from waste oil, usually from restaurants and takeaways. Okay, it keeps cost competitive with fossil fuel diesel. Okay, so we're getting like the companies that do this are very small because it's not very profitable. But what they do is they take away waste oil from companies who would usually be paying for that waste oil to be taken away and dealt with in some manner, probably combusted. So these people are going around taking this away for free, and they're making their biodiesel and then selling their diesel for profit. So that's the idea. There's not too much profit in it. That's why it's not huge. There's only a few small companies around who do it. It's usually like one or two person job kind of thing with a small van and a little backyard operation. They can do it. All right. It does have a lower energy of combustion than fossil fuel diesels, but only 9% lower, okay? So not too much, okay? There's a good little TED Ed video about biodiesel, the afterlife of oil, like that. Okay, so here's the cycle of biodiesel. Where should we start? Okay, we're getting oil from crops, so like sunflower oil. We're getting the seeds, we're crushing that and doing a few chemical extractions to get some oil out of it, and then we're refining that a bit more, and then we're doing a chemical reaction called transesterification, which we'll discuss more in depth next chapter when we learn about esterification. Okay, what you're getting from that is a byproduct, glycerol, and you're getting these biodiesels that can then be used in vehicles. And from memory, I could be wrong because I'm not too mechanically minded, I think most diesel vehicles have no issues dealing with biodiesel, or it just needs a very, very rudimentary slight change. Okay, from memory, it's not much at all. Okay, you're getting energy to move vehicles. It's still combusting and producing CO2, but on that ideal thing, that CO2 is then being taken up by the next crop. A bit naive, but sure, you could argue it. Okay, the chemistry of it, we're going to discuss next chapter when we learn about esterification. Okay, so don't worry a bit too much about it now. Okay, next slide is just a summary table of some facts. I thought this would be quite handy. I saw something similar in another source, so I put this together. A lot of the past HSC questions and exam questions talk about the benefits and comparing and contrasting, just like the syllabus dot point said. So here's a nice table. We've got biofuels and fossil fuels, comparing them. All right, we've kind of learned about this first, their composition. We know about the sources, okay? CO2 permissions, or just emissions. So the idea between biofuels is that the CO2 produced during combustion, transportation, manufacturing gets recaptured in future crops. That's the idealistic way. Not actually completely true, but that's the idealism there. So the combustion of transportation manufacturing produces large amounts of CO2 that have been captured millions of years ago when contrasting it to fossil fuels. Look at the heat of combustion differences. Now, these numbers you do not need to know, of course, okay? But just realize, look at biodiesel. Biodiesel's just 41 compared to 42.5 kilojoules per gram, so just slightly under, if you remember that. That's pretty good. But you can see that ethanol is about half of the other ones, okay? Negative impacts. Crops take up space and resources, delays use of solar and wind. I like that important fact. We've got solar and wind technology. It does a brilliant job. All we're doing is stopping the inevitable, what should be the inevitable. So yeah, I like that. Delays the use of solar and wind. We should be doing that anyway. Okay. Negative impacts of fossil fuels, huge. We've talked about them before, but there they are too. So hopefully you find that table nice and handy. Okay, there's a worksheet for you to do with some good long form questions. Okay, look at that. We have talked all about alcohols, and I'm going to leave it there. I've ranted enough. Thanks, guys.